Going along with similar triangles, we have specific parts of similar triangles that are used to help set up different types of proportions. So we're going to take a look at those next. The three specific parts that we're going to look at are altitudes, angle bisectors, and medians. So those are the three things, and with each one we can set up a different type of proportion. So looking at our altitude is what cuts a triangle from a corner and forms a right angle down below. So line BD in this first triangle would be the altitude, and line FH would be the altitude. With our proportion, we can say that those altitudes are proportional to sides of the triangles. So when I write that out, I'm going to have BD over FH, so my altitude for the first triangle over the altitude of the second triangle, is equal to a side for one triangle and a side for the second triangle. Notice that AB and EF are in the same position on the triangles, so it's important to use that. We could also use BC or FG as long as we're using the same side for both triangles. Looking at the angle bisector is line QS and line UW. It's what cuts my angle directly in half. When I set up that proportion, it's going to be the angle bisector line, so QS over UW is equal to the side of my triangle. So in this case, we're going to use QP over UT. Again, we could have also used QR and UV, but just making sure we're using that same part in each triangle. And then the last type of part that we are going to look at is a median. So a median is HJ and LN, and I know it's a median because it's splitting my bottom part in two equal halves. So JG and JI are congruent to each other, and KN and NM are congruent to each other. So that's how I know it's a median. Again, setting up our proportion, we're going to use the median for each triangle for one part of our proportion, and on the other side, we're going to use a side. So in this case, we're using GH and KL, but we could have also used HI and LM. So that's what we're going to use to solve these next few examples. Looking at example number 1, they told us that we have similar triangles. So this little squiggle right here means that I have a similar triangle. So STU and DEC are similar. We can still match up our points using the way we did for congruent triangles. And we want to figure out the value of X. So X right here is in fact my median length. I know that because of my picture markings. Again, if it's marked with two equal halves on a side, that means I have a median. When I set up my proportion, I'm going to use X over 15 for half of it. The other half is going to come from my sides. So with my sides, I'm going to use 16 ST and 20 DE. Again, ST and DE are matching each other in my similarity statement. Doing our cross product, we have 20x equals 240, and we find that x equals 12. Number 2 is an example of our altitude. Again, the altitude goes from a corner straight down, and it creates that right angle at the bottom. So when I set that up, that's going to look like 10 over 8. I'm doing the first triangle to the second triangle, so 10 over 8. And then my side, I have x for HI, and then for KL, I have 14. And then solving for x, we find that x equals 17.5. Number 3 is an example of an angle bisector. Again, where we have angle C and angle F. We see that it has those two little marks on each side, so that tells me that it was split into two and they are congruent. So setting up our statement for this, we have 32 over 24, that's the angle bisector, over 38 equals 38 over x, which is our sides. So matching it up, 32 and 38 are for my first triangle, 24 and x are for that second triangle. And then when I solve, I find that x equals 28.5. Number 4 is also an example of an altitude type of problem. In this case, they dropped that altitude down on the outside of my triangle, but I still have that right angle marking, so that's what tells me it's an altitude, and I'm still going to use that to set up my proportion. So setting up our proportion with the altitude, we have 12 over 15 is equal to x over 42. And then solving, we find that x equals 33.6. We are going to skip number 5 for now, but number 5 is an example of a median problem. Again, looking at those markings just so we can tell that. We're going to instead skip down to the triangle angle bisector theorem. So that says that an angle bisector in a triangle separates the opposite sides into two segments that are proportional to the lengths of the other two sides. So looking at this picture to the left here, we see that we have our angle bisector, and our bisector is BD, line BD. So when I set up our proportion, what the triangle angle bisector theorem says is that I can use those sides, so BD split up side AC into AD and DC, so that's the first part of my proportion, AD to DC, and then I'm going to match it with its other side in the triangle. So that's equal to AB over BC. Doing some examples with that, number 6, we're finding x. KM is my angle bisector, so when I set up that proportion, I'm going to have 4.8 over x is equal to 12 over 18. So 4.8 and 12 are for my first little triangle, and x and 18 are for the second triangle. Solving, I get that x equals 7.2. For number 7, again, looking at our triangle, KM is our bisector. So setting up that proportion, we have 40 over 36 is equal to 54 over x. And when we solve for x, we find that x equals 48.6. A couple more examples that we're going to look at. For number 8, we see that they tell us this side for JL, so that's 39, so I'm going to have to subtract to figure out what LM is. When I do that, I'm able to set up my proportion and say that 15 over 24 equals x over 36. And when we do that, we solve and we find that x equals 22.5. Number 9, this time they said x is my whole length of JL. So when we subtract, we're going to do it something a little bit different that we haven't looked at yet. We are still setting up our proportion, but to figure out what LM is, I have to write that as an expression. Well, if the whole thing is x and I take 12 for JM, I can write the expression for LM as x minus 12. So I have 12 over x minus 12 is equal to 18 over 30. And when I simplify and when I solve for my x, I find that x equals 32. Number 10, 45 marks JL, and I want to figure out what LM is, so I'm going to subtract 27 from 45, and I'm going to set up my proportion as 27 over 18 equals 3x minus 9 over x plus 11. So matching up the sides of my triangles correctly, when I do the cross product, we get all the way down to x equals 17. So again, that was using our triangle angle bisector theorem, and we also took a look at altitudes, angle bisectors, and medians, and setting up proportions with that. So those were all of our different parts of similar triangles.